So, welcome to lecture number 29, and we have been discussing about instantaneous power in AC circuit. Mind you, AC means sinusoidally excited circuit. Okay. And we have seen that if it is an RL circuit, there is voltage waveform black one, current will be lagging this, then you divide several intervals following this rule. Wherever zero crossing has occurred both for voltage and current, you mark them with bullets, draw vertical lines and say during this period voltage is plus, current is minus. So, negative power, but I am calculating power delivered by the source, because this is how I have assumed this, as if it looks like it always delivers power. So, V t into I t, mind you, gives you power delivered, but in a scenario like this, I also know this one, this product will sometimes become plus, sometimes will become minus. So, if somebody writes in language power delivered to the load is 50 watt, so 50 watt, correct. But if somebody calculates at some other instance that power delivered to the load is minus 10 watt, what he is indicating? He is telling that at that time source is absorbing power and load is delivering power. Can load deliver power? Yes, because there is energy storing elements. Inductance sometimes will pump back power to the supply. Anyway, so we plotted then the instantaneous expression of calculated the instantaneous expression and got this power, and we found that there is a positive power average can be found out, which I will do right now. And we say the circuit absorbs so much watt of power on average. But another way of looking at this one, that this is much more nicer way, that is what I want to share with you. So, your thing was like this, we will play with those equation a little more. So, this was my circuit, this was the voltage, AC voltage, sinusoidal voltage, and this was current. Of course, while solving this current for this current, I have taken help of the phasors. Now, I am trying to interpret about the power. So, I have come back to time domain and trying to indicate the things. So, what did I do? I told you let V t is equal to V max sin omega t, I t is equal to I max RL circuit. So, sin omega t minus theta. What is I max? Do not forget, I max is equal to V max by Z. This Z, is it a phasor? No, it is magnitude, without bar I am writing. Okay. Z is root over r square plus omega square L square. What is theta? Tan theta, from this expression I can calculate, or theta is tan inverse omega L by L. So, I have solved the circuit, I have these results before me, then I calculated the instantaneous power, which if you calculate, this I wrote last time, V max I max sin omega t sin omega t minus theta. This is the thing. Achha, now you see what I am doing. This power, instantaneous power P t will be equal to V max I max, it is there, and this is sin omega t. I will write it like this, and this sin omega t minus theta I can write it as sin A cos B minus cos A sin B. Mind you, theta is a fixed angle, omega t changing with time, sin theta, tan theta is fixed for a given circuit omega L by R. So, this is how you write. Then also this one you break up in this fashion, V max, I max cos theta first term into sin square omega t, this first term minus V max I max sin theta and then sin omega t cos omega t, sin omega t cos omega t. This way I can write, is not? Fine. Now, this can be written as V max I max by 2 cos theta. So, by 2 and 2 sin square omega t, 2 sin square omega t can be written as 1 minus cos 2 omega t, is not? This is the thing, minus this one also can be written as V max I max by 2 sin theta and this 2 into sin omega t cos omega t is sin 2 omega t. This is what I have done, written it. Now, this instantaneous power, it is cleverly broken up into two components just by simple trigonometric manipulations. Now, look at the first term very carefully, this term. This term, if you look at, it will remain always positive, it cannot be negative. I will sketch and show you. And this one, since sin 2 omega t alone is, sin theta is constant, cos theta constant, and this term, so this term will never become negative, will never become negative. This term, since sin 2 omega t both plus minus excursion, it will be having both positive and negative excursion about omega t axis, equal, having both equal positive and negative excursion. Choose any value of omega t, you put, it will be always positive or at best it can be 0, but it will never become negative. Now, this equation helps us to understand much better sorry, I will take it from this, copy it and I will paste it here. So, this is the thing we have written there and I will erase this quantity. So, this is the instantaneous expression of the power. Now, this one I would like to sketch, this term I will sketch, then this term, and it will be easily understood what I am trying to say. So, this is suppose the thing I will do. Now, this term is nothing but V max I max by 2 into cos theta. This bracket I am opening, got the point? This term only I am writing V max I max by 2 cos theta minus V max I max by 2 cos 2 omega t, cos theta cos 2 omega t, cos theta cos 2 omega t. So, it will be a DC value, this one is constant, B max I max by 2 cos theta is constant. So, I have to add to get this component, this is the DC component. Suppose this level is V max I max by 2 cos theta, this constant, this is a constant number. Then to this I have to add a cosine 2 omega t term with a negative peak values. So, it will be just like this. The sum of this a negative cosine value, which will then go like this. What is this level? This will be also these two are equal, this will be 2 V max I max cos theta, this whole thing. Got the point? This is the only the first term I have sketched. So, this is the first term which has been sketched here. This term I have not sketched. Clear? And you see this quantity will never cross 0 and come negative. At best it can become 0 at some times. So, this term will basically tells you that power absorbed by the circuit always positive. Then I will sketch this term. I will sketch including this negative, this term I will sketch. How it will look like? It is simple, sin 2 omega t. Okay. So, once again I sketch it here. Mind you, I am sketching against omega t. Always whenever whatever you are sketching, show the axis very clearly. So, this is omega t. You can identify the value of this omega t. How much is the value of this omega t? Here it has to be pi by 4. At pi by 4, if you put it is pi by 2 0, and at this point the value is V max I max cos theta only, this one. If you put pi by 4 in this expression, cos pi by 2 is 0, and you will be left with V max I max cos theta by 2, and this one will be how much? Cos pi by 2 this should be. Why? Because at pi by 2 this is cos pi minus 1 minus minus plus 2, 2 cancel out, and this whole length is V max I max cos theta, because these are this. So, this whole thing is V max I max cos theta, that it is doing. Then once again from symmetry it will I can easily. So, pi by 2 plus pi by 4, it will be how much? 3 3 pi by pi 4 and so on, and it will be 0 here, you can find out. Now, I have to sketch this one. This you see, it has got a peak value and sin 2 omega t. So, it will have a both plus and minus excursion. So, I will also sketch that the second term, and its value is V max I max by 2 sin theta. Now, the question is, if it is pi by 4 at this point, it will have peak value, is not. So, I am now sketching this term V max I max by 2, this is nothing, V max I max by 2 into sin theta is the peak value of that sine wave into sin 2 omega t. This I am sketching. So, at omega t equal to pi by 4, if you put sin pi by 2, so it must have that peak value occurring at pi by 4. So, it is a sine term with this peak value. But anyway, I have to add to this, I have to once again subtract. So, minus of that will be like this. Oh, sorry. So, it has to start from 0 and it will reach maximum here at omega t equal. So, it will be like this. Then at pi by 2, you see, if you put pi by 2, sin pi is 0. So, it must reach 0 here. Is not? And then once again it will reach maximum, and once again it will reach 0 and go to negative. But this is sin 2 omega t term. It will have both positive and negative excursion. So, second term of p t, and this one is first term of the p t, that is what p t. Therefore, instantaneous power absorbed by this R L circuit, we are now going much deeper into it and trying to understand what is happening here. So, this is your V t, this is your I t, and this first term, that is this term, I understand that it always delivers power to the circuit, because this red one is always positive, sometimes it is becoming 0, but never coming negative, and this one is the power which is oscillating between source and the load. So, a double frequency oscillating power, double frequency oscillating power. Got the point. And what is the peak value of this one? Peak value of this one is V max I max by 2, V max I max by 2, that is all, and it is omega t I am sketching. So, this is pi by 4, this is pi by 2 and so on, 3 pi by 4. Okay. Therefore, it is this power which is flowing to and fro between the source and the load. Sometimes power is absorbed by the load because inductance is there, sometimes power is returned back to the source. But this is the average power which load is absorbing. This is the average power this whole against time, this much power is absorbed by the source, but on an average load is absorbing average power absorbed by load is this line. And what is that value? That value I will write it as P average is equal to V max into I max by 2 into cosine theta. And this term which represents the power oscillating between source and load has a peak value whose value is V max I max by 2 into sin theta. I forgot another term, sin theta, this peak value. Peak value will be this. Now, therefore, we say that the power which will be oscillating between source and the load will be called reactive power. It is never consumed by the circuit. So, this is the origin of reactive power. And this power which is absorbed by the load or consumed by the load is called the active power. Okay. Therefore, in AC circuit, when things are sinusoidally excited circuit, when things are varying, both voltage and currents are changing with time, no point in talking about instantaneous power. It is better you tell me how much average power I am consuming, is not? That will be much more meaningful than to calculate instantaneous power. At this instant I am consuming this much power, this. No. Your electricity bill should be prepared based on the average power you are consuming. After all, it is only 20 millisecond one cycle of the supply, is not? In the previous circuit, this is 20 millisecond. In 20 millisecond, how much energy you are consuming? Okay, average power into that time. Based on that, your how much power you are consuming should be calculated based on the average power. Clear? Therefore, this is the thing. Now, so this P average, now we make an important statement. In AC circuit, therefore, in AC circuit, we have seen what I bar current in the circuit is V bar by Z bar we have seen, just like your DC circuit. Only thing this time the numbers are complex, and P average is V max I max by 2 into cos theta, that is the real power, which real power that I have explained just right now. So, this is the thing. So, only thing in DC circuit, current in DC, I will just jot down here, in DC current is V by R, power is V into I, is not? Now, here is in the expression of the average power, we find peak value of that sinusoidal voltage into peak value of the current, but there is a factor 2 appearing. It is nothing wrong, one can live with this. Apart from this, this term of course cos theta will be always there. So, this expression is written like this: V max by root 2 into I max by root 2 into cos theta. And you know V max by root 2 is nothing but RMS value of the supply. Sinusoidal varying quantity with time V max sin omega t, what is its RMS value? V max by root 2. Similarly, current is also sinusoidal, what will be its RMS value? It is IRMS into cos theta. Sometimes people just do not write RMS, they understand once you write the average power consumed by the circuit is VI cos theta, it means V is RMS, I is RMS. Got the point? Now, after knowing this, so it is quite then similar to that of DC circuit, only thing one factor comes cosine theta, that you of course, you cannot avoid, it cannot be product of voltage and current, RMS value of voltage and current, except for resistive case when theta is equal to 0. But anyway, we will live with this P average is voltage and current. And last one thing I will add, while defining the phasors, I told you, suppose I told you that Z bar is equal to voltage phasor divided by current phasor. And these voltage phasors I defined in terms of maximum values, say V x 0, and current phasor also I wrote like this: I max some minus theta, is not, for RL circuit. Is not, this is what I wrote, but that is phasors were represented by the peak values. There will be absolutely nothing will be wrong if you divide this by root 2 0 degree and I max by root 2, both numerator and denominator you divide by root 2 and write like this, and say that while representing the phasors, I will represent in terms of RMS quantities. That is, I will write V RMS 0 degree divided by I RMS theta. So, your Z bar remains unchanged. Therefore, at the end what we will be doing, what people do is that if any sinusoidal quantity is there, suppose I say that V t is equal to some 245 volt sin omega t. Then while telling in terms of phasors, what I will do, V bar I will henceforth take its RMS values, that is 245 by root 2 angle 0 degree. Z bar does not change, it is equal to R plus j omega L. So, I will calculate Z bar. Then if you calculate I bar from this V bar by Z bar, you will get obviously IRMS minus theta. Therefore, representing in phasor notations, because to get similar expression for power as in DC circuit, similar not identical, cos theta is there. This cos theta is called the power factor of the circuit, power factor of the circuit. So, how nice it is. Therefore, in a circuit, sinusoidally varying voltage, sinusoidally varying current, and they will have in general some phase displacement between them. So, sometimes the instantaneous product of voltage and current will become plus, sometimes minus. If you are using some power in the circuit, there must be some average value. Okay? So, this thing, to summarize once again I am telling, this is the expression of the average power just from this. This is the expression of the instantaneous power. Then we intelligently broke up this two into two terms. One term is always positive, it will never have negative. This term never becomes negative, it may come to 0, that is there. And there is another term which is also a double frequency term, and this will have identical positive and negative excursion. So, average value of this quantity is 0, no doubt about it. From this, if I sketched this waveform, first term I have sketched, and as expected there was no negative value of this first term, it will be 0, oscillating no doubt. So, it will have an average value, and that average value will be V max I max by 2 cos theta, because average of cosine 2 omega t is 0 all the time, is not. If you calculate average over a cycle, sine cosine terms average value is 0. So, this will give you 0 value. So, this is the average value V max I max by 2 cos theta. And the second term, which is only having sine 2 omega t, no DC term as added to it. So, it will have identical plus minus excursion, and it will continue like that. So, sometimes the circuit will absorb power from the source, and sometimes some other interval it will return back the same power to the source. That power will never be consumed by the circuit. Your electricity bill is consumed on the basis of this average power you are consuming. We will in the next class tell you something more about this power factor and its implication. Thank you.